Hello everybody, welcome back to iBuddy Science, and today we're going to be solving circuits. Now, this is typically one of those topics in science that a lot of people find pretty struggling because there's a lot of things that are coming at you at once, but I think if you break it down and really try to understand what is happening fundamentally, this topic becomes pretty easy when you think about it from a broad perspective. So let's just start off right away. We're going to start off with some basic notation. And this includes things like current, potential difference, which is also known as voltage, and resistance. Now, from the past two lessons, you're probably pretty familiar with what these are. Current is basically that movement of electrons. Potential difference is the difference between the cathode and the anode in the battery. And that's basically what the voltage is. And the resistance is basically resisting the current, so it makes it slower. So, for example, we also have annotations like here. T means total, so IT means total current of this entire circuit, and 1 and 2 is referring to individual loads. So, current at the second load would be considered as I2. Now, this is pretty important when you're doing your calculations because let's say I want to talk about I1, which is the first light bulb. Well, I can't really just put it as I because that could mention a bunch of things. That could be the total, that could be another load. That's why you have to specifically mention which light bulb you're talking about. So let me just show you guys real quick. Here, let's say we have a circuit and we have two loads. Let's say we have one right here. Say we also have one right here. We would have to consider this one to be anything considering this would be considered the first one. So I1, let's say. You have to label that. And this one would be I2. So it's very important to label these things correctly. So let's try these. Now, this is also something that you may have been familiar with. This is basically how all of these quantities basically function in series. So the current is always the same when it's in series. In voltage, you add all of them, and resistance, you add all of them. So in series, it's pretty straightforward with these. Same, add. Now in parallel, it's a bit more different. Now, prior to before, where the current is the same, when the loads are in parallel to each other, that means that you add the currents. When the loads are in parallel, Now, when the loads are in series, you add all the voltage, while when the loads are in parallel, the voltage is the same. And in series, you add all the resistance, while in parallel, you simply add the reciprocals of it. And this means that when you add the reciprocals, your RT is on the bottom of it, which is your total resistance as we mentioned earlier with the notation. So you're going to have to reciprocal your answer. So let's say you get the answer as 1 over 8, then it means it's 8. So you have to make sure these swap, the numerator and the denominator. So let's do the brightness of the bulb. In series, that increases the resistance but decreases the brightness. While in parallel, it decreases the resistance but the brightness doesn't necessarily change. If you think about this, it's because all of these in parallel are from the same, they get the same amount through each of these lines. While in series, they all have to divide all of that into one single line. So here, as you see here, there's another diagram of it. We have the same bulbs, which is the same brightness, or different bulbs, which is different brightness. This is a pretty good way of thinking about it. So let's do a practice problem. Now, first thing we have to do is draw a schematic diagram. So that schematic diagram would be, let's think. So we have a 5-volt battery. We have an ammeter. And we have a resistor of 10 ohms. So let's first draw a diagram. Since we assume 2.5 volts per cell, 5 volts divided by 2.5 means we have 2 cells. So we draw in 2 cells. positive like this, like that. Label that as the negative side. Now it's asking us, so this, now we just label that as 5 volts real quick, even though it's kind of self-explanatory. From there, what we can do is create a line. It's asking for an ammeter. An ammeter symbol is simply an A. And it's also asking for a resistor, which is just a squiggly line. So this is where we got it from. Now we really need to it's asking us to determine the reading on the ammeter. And essentially what that's asking us is the current. So we can just label that down as 10 ohms. And our ammeter, we can just write that down as X for now. So, current, we know that current's relationship in Ohm's law, V equals IR, is I equals V over R. I, the voltage of it, is 5 volts, and the resistance is 10 ohms, so the current is 0.5 amperes. And that is our ammeter's readings. So if you want a little bit more of a cleaner diagram of that, this is essentially what's happening. We have our I equals V over R, 5 volts, 10 ohms equals 0.5 amperes. So here's another practice problem. If voltmeter A reads 12 volts, what is the voltage of lamp B? Now if the ammeters read the same amount, what does this tell us about the resistance of the two branches? And if the current through lamp A is 4 amperes and the lamp B is 6 amps, what is the total current of the circuit? So let's just first break it down into the first one. Now, we have two strategies for this first of all. We could first of all use Ohm's law, or we could use VRI of series versus parallel. So here's that table that it's basically just a simplification of what we talked about earlier. The current in series is the same as a recap. The current in parallel is added. The voltage is added in series, while in parallel is the same. And the resistance in series is added, while in parallel you add the reciprocals and you reciprocate it at the end. So let's take a highlight of our electrical quantities real quick. It's asking for the voltage, and it also uses the word parallel and series. So let's talk about this. Here our table says that in parallel, the voltage is same. And in our case, if voltmeter A, which is this one, reads 12, what is the voltage of lamp B? Lamp B would be this one. So in that case, this would be 12 volts. That is because these lamps are in parallel, so they have the same voltage. As here, that's the same thing that I was talking about. 12 volts, so lamps are in parallel, so they have the same voltage. Here is another problem. If the ammeters on both of the branches read the same amount, what can we conclude about the resistance? Now, first thing you have to understand is that since the voltage and the current is the same, then the resistance must also be the same. This is part of those fundamental laws that we were talking about earlier with the table. It's very important to know this table well, because this is one of the most important things about the topic. So as you hear, we can conclude that the resistance must also be the same. So if the current at lamp A is at 4 amperes and lamp B is at 6 amperes, what is the total current of the circuit? Now it's currently using the word parallel. It's not using the word parallel, but basically they're in parallel. So we add it up because it's asking about the current. From here, IT, since when it's in parallel, you add it up. The current total is just going to be 4 plus 6. Based on the values it just gave us of lamp A and B. So it gets us, and you should also preferably write A beside it. So it's preferably 10 amperes. So, from here, we have another problem. This is basically just a cleaner way of saying what I just said. So, yeah. So, practice problem 3. Determine the potential difference across the source and determine the missing current readings of the bulbs. Same. So, we know the resistance of the bulbs are the same. We know, first of all, so for one, let's start off with one. Potential difference, that's just another word for voltage across the source. So, let's first start off with a grasp strategy. What do we already know? What are we trying to solve? And how do we solve? We do know that we have that 1 volt right there. We also do know that our voltage too is 1.5 volts. What we're trying to solve in our case is the total voltage, because that's the potential difference. And the way we solve it is that since they're in series, we just add the voltages up. So the total voltage in this case would be 2.5 volts. So we can write that down, 2.5 volts. Now, moving on to the next one over here, which is the same strategy, grasp. What we know, what are we trying to solve, and how do we solve this? So, we know almost nothing here. The only thing we know is that this is 2.5 amperes. So, let's first of all understand that we don't have any voltage, we don't have any of that. So what do we have to do? Well, the first thing we can understand is that the subscripts for the total can be added as the current of the first one and the current of the second one. Sorry. This one and this one. And we know that since the total resistance will depend on the cell, which is something we don't know, the total current will be found by adding all of them together. Now we also know that the resistance will be adding, this is the reciprocals. Let's leave that info for now because the question is kind of asking about current. So, I guess what we could do is, we could understand, let me think. This is probably also 2.5 amperes. It's because V and R are the same. From here, the total is probably going to be, it's going to be 5 amperes because you add up the 2.5 and 2.5. From here, I would say so that's 5 amperes. This is 2.5 amperes. That's pretty much there for that.